everyone. Today we are going to learn 5.6 calculating centers of mass and moments of inertia. Okay, so let's take a look. So what is the center of mass? So this is related with 2.6 from Calculus 2. So please watch YouTube Calculus 2 2.6. Yeah. Okay. So center of mass. So if we have a uniform density, this means constant density, then we say that this is centroid. Okay. All right. So we have a moment of inertia. So this one measures the tendency of mass to resist a change in rotational motion about x-axis. X-axis, it can be y-axis too, because we are going to make a two-dimensional here. So about x, just axis. I think I copied wrong, just axis. On axis, it's better. All right. So very similar concept with the previous one. So we have lamina. So we have a thin plate. Yeah, then we take the, we have all the rectangular here, and then we take the one small rectangular there. We call this is mass. Yeah, and then we make a subdivide from that rectangular strip. Then we take the Riemann sum. Then, ta-da-da. We have the formula, right? So we make a double integration. And we have rho. This is in Greek letter. Density function. So dA area, right? So we make a dx, dy, right? Okay, so density function, we have two different functions. One is the constant function. Constant function, we say that just number, right? So rho equal to 2, right? That's the one of the example. And we have a variable function. Then we say the rho of xy equal to xy. Yeah, that's just a random example. All right, so let's do calculate. Yeah, all right, so we have a triangular lamina or with the points with the density. Aha, here we have a variable function. Yeah, okay, find the total mass. Okay, we have formula here, total mass. Then we are using double integration with the density function. Yeah, okay. So I draw here and then I wrote down the formula. Okay, so we have 0, 0. And we have 0, 3, right? And then we have 3, 0, right? Okay, I connect, that is a triangle, right? Okay, so this line, we can see that y-intercept at 3, then negative slope, so negative x, yeah? Okay, we take the tiny mass, we denote the symbol as dm. dm means tiny mass. There is a nice vocabulary, but it's too long, so I just made it tiny. Yeah. So that will be the density function. All right. Okay. Now this formula we got from above, right? Okay. Let's do it. Since we have y equal to negative x plus 3. So we want to integrate with respect to y first, right? And then the x is a number, so it's better. We get the mass in the number, right? All right, so let's do it. So we have x equal to from 0 to 3. And then y equal to 0 to negative x plus 3. Okay, then density function given xy there. Then dy dx. All right. Then we do integrate respect y. So do first, then treat x as constant. All right, so we will have x equal to 0 to 3. All right. Oops, 0 is missing. X is constant, so we keep the constant, right? And y, we integrate, so y squared over 2. Yeah. And we want to evaluate from y equal to 0 to negative x plus 3 dx. Okay. X equal to 0 to 3. X over 2 is the constant. Y squared, so we will have, let me make 3 first because the positive. Then dx, yeah. All right. Let's simplify. So we have x over 2 and the formula a squared, so 9 minus 2ab, so 6x plus x squared, right? And dx. So there will be x equal to 0 to 3 and 1/2. Let's leave. And then we distribute. So we have 9x minus 6x squared plus x to the third power dx. Okay, now integrate, right? So we keep the constant and integrate with respect to x, 9x squared over 2 minus 6x to the third power over 3 plus x to the fourth power over 4. And then we want to evaluate from 0 to 3. Okay, now 1/2, 9 over 2, 3 squared minus 6 over 3, which is 2, 3 to the third power, and 1 over 4, and 3 to the fourth power. Then rest is 0, right? Okay. Can you please calculate? Okay, so did you get 27 over 8? So the unit is kilogram. Good job. Okay, now we have a moment. So what is a moment? Moment is quantify how much a force causes an object to rotate around a point or axis. So in that case, we want to make a moment about the x-axis. Then let's take a look. We have a Riemann sum, everything, right? Then we get the formula y times of that density function, right? Okay, then why we have moment in terms of x-axis, but why you would put the y? Because x-axis here, y-axis there, right? So x-axis with the and then yeah, and then we rotate to the y-axis. Yeah, that's why we put the y. Yeah. Okay. Same concept. We have a moment and about the y-axis, right? But then we have a Riemann sum, and then eventually we get the formula x times of the density function, right? Okay, same as y-axis here, then we rotate to the x-axis. That's why we put the x there. Make sense? Okay, then we are using this formula to find out those moments, right? Okay, so same problem. All right. Okay, let's do it. The formula. So we have m sub x about x-axis. So we said m sub x. Okay, so m sub x equal to we have double integration reason, right? Y times rho density function. Okay, so we had y equal to negative x plus 3, right? So same, we are using integrate to y first, then x. Yeah. All right. So let's do it. X equal to 0 to 3. Y equal to 0 to negative x plus 3. And then we have y there. And then density function xy. Okay, so let me write down for you. So this is y, right? And this is rho density function, right? Okay, so dy dx. All right, so we have x equal to 0 to 3. We want to integrate with respect to y first. Then we treat x as a constant. All right, then x is constant, we keep that, and then we have y squared there. Let me do. So this is x times y squared, yeah. So we can make y to the third power over 3, yeah. All right, so we do evaluate from y equal to 0 to negative x plus 3. All right, then we have x equal to 0 to 3. And then x over 3, y to the third power. Let's do different order. So 3 plus minus x to the third power dx. Okay, so we have x equal to 0 to 3 and x over 3. Let's using the formula a minus b to the third power, a to the third minus 3a squared b plus 3ab squared plus b to the third power, right? Is it negative? Yeah, negative. Third power. That's why negative. Hold on. Let me arrange it. All right. Minus b to the third power. Okay. Let's do it. All right. So the first one, third power, so 27. And minus 3 times a squared, so 27 again. And x plus 3 times a times b squared, so 9x squared. minus the b squared, which is x to the third power, right? Please correct me if I make a mistake. All right. Then let's integrate. Oh, let's distribute it first. So we have x equal to 0 to 3, 1/3, 27x minus 27x squared plus 9x to the third power minus x to the fourth power dx. Yeah. Okay, now x equal to 0 to, let's integrate. So we will have maybe, hold on 1 second. Since we can divide by 3, right? This is much better, right? Sorry about that. Normally I keep the constant outside, but all right. So x equal to 0 to 3. Oh, why I erase? Hold on 1 second. Okay, sorry. Crazy. Okay, so I distribute everything with x over 3. So we have 9x, negative 9x squared, 3x to the third power, 1 over 3x to the fourth power. Yeah. Okay, let's integrate. So 9x to the second power over 2 minus 9 x to the third power over 3 plus 3x to the fourth power over 4 minus 1/3 x to the fifth power 1 over 5. Yeah. And then we want to evaluate from 0 to 3. Okay, 9 over 2, 3 squared minus 3, 3 to the third power, 3 over 4, 3 to the fourth power, minus 15, 3 to the fifth power. Luckily, other side is 0. Okay. Can you calculate? Okay, do you get 81 over 20? All right. Let's do moments about y-axis. So we have a formula, integrate, double integration, x times the density function, right? Okay, so let's do it. Moment about y-axis. So we denote m sub I equal to double integration reason x times density function dA. Yeah. Okay. So we are using same limit. So x equal to 0 to 3 and y equal to 0 to negative x plus 3. And we insert x. And then we had the experience x times y for the density function, right? So we have x, and this is density rho. Okay, dy dx, yeah? Okay, so let's integrate with respect to y. So there will be x squared y then, yeah? So the first, treat yx constant. Sorry. Crazy. Constant. All right. So we have x equal to 0 to 3 and y equal to 0 to negative x plus 3 and x squared y, right? So x squared constant y squared over 2. Ooh, told you, crazy. Oh, and then okay, so we do evaluate from y equal to 0 to negative x plus 3 dx. Okay, so x equal to 0 to 3 and x squared over 2 and 3 minus x to the second power dx. All right, so we had the experience that form. So we have 9 minus 6x plus x squared dx. And let's distribute. So we have 9x squared over 2 minus 3x to the third power 1/2 x squared dx. Let's integrate 9 over 2 x to the third power over 3 minus 3x to the fourth power over 4 plus 1/2 x to the third power 1 over 3 from x equal to 0 to 3, right? Okay. Uh, 3 over 2, 3 to the third power minus 3 over 4, 3 to the fourth power, 6, 3 to the third power. Yeah. Can you please calculate? So we get also 81 over 20. Okay. Okay, very good. Okay, now we have a center of mass. All right, so center of mass, we indicate x bar. Let me write down, read x bar. Because from the calculus 2, we had this section, center of mass. We are using the weighted mean formula. That's why. So we are using x bar. And then this for x coordinate. We have y bar center of mass for y coordinate. Yeah. Okay. So we have a moment there, right? So this is a moment. And this is mass, right? So moment about the x-axis. Sorry, moment about the y-axis. Yeah, we are using different because in the formula we have x there, right? This formula from the calculus 2, we had one. Yeah. So because let me try to think the formula. Okay, so I wrote down the formula from the calculus 2. So x bar center of mass for x coordinate. So we have a summation of the product of mass with the x values. Yeah, divide by the sum of all the masses. So this one we did indicate m sub y. That's the moment about the y, right? But then the formula said that product of the mass and x. Yeah. Okay, same reason, same concept with the y bar. So we had the formula from the calculus 2, which is m sub x, because this one is summation of product of the mass with all the y values, yeah, over the mass, the summation of all the mass. But then calculus 3, we have m sub y moment about the y, right? Then we had the formula from earlier, previous, right? What's the mass formula? So we are using double integration of density function, right? Okay, now we have formula, we have the example. Now we want to find center of mass, yeah? Center of mass. All right, so I wrote down those formula here. Okay, then we found the moment earlier. So let's find out where is the moment. This is, oh, right there, yeah. Uh, so moment about the y-axis. So we have 81 over 20. So 81 over 20 over the mass we found in the previous one, the first question, right? So mass, let me find out. Uh, yeah. So this mass, right? This is the mass. So 27 over 8. Okay. 27 over 8. 27 over 8. Yeah. Can you please calculate? So we have a 6 over 5. Yeah. Okay. Now we want to know about the moment about x-axis. Let's find out x-axis. This is also this number, right? X-axis. Okay, so there will be 81 over 20. And the mass is the same mass. So we have 81 over 20 over 27 over 8, which is 6 over 5. Yeah. Okay, so therefore, the center of mass is the point. 6 over 5, 6 over 5. Yeah. All right. What if the density function is the constant, right? Let's talk about that. Okay, so what if we have a density function equal to 1, which is uniform density we talked in the beginning, right? So uniform density means mass is uniformly distributed. So uniformly means evenly distributed. Yeah. Okay. Now we have the formula. Let's do it. So this is takes a little bit work because we had all the information earlier, right? So okay. Let me put this on later. Okay. We're using same limit. So x equal to 0 to 3 and y equal to 0 to negative x plus 3 and x and then rho equal to 1, right? And then the y dx. Okay. Equal to 1. Okay, we want to integrate with respect to y, right? Treat x as constant. All right, so we have x equal to 0 to 3. And x is a constant, keep that, then y, right? Y equal to 0 to negative x plus 3 dx. Okay, now x equal to 0 to 3. X minus x plus 3. Luckily 0 other side, other limit, and then dx. Okay, so we have negative x squared plus 3x dx equal to x equal to 0 to 3. Let's integrate, yeah. So negative x to the third power over 3 and plus 3x squared. Wait a minute. I did not do this one, huh? Yeah. Yeah, maybe we do later. This is only the numerator, right? So this will be r x o x y equal to, yeah. Okay. Plus 3x squared over 2. We want to evaluate from x equal to 3, 0 to 3. So negative 3 to the third power over 3 plus 3 over 2, 3 squared. Okay, what do you have? Okay, 1 cancel. And we have this will be negative 9 plus 27 over 2 equal to, then we get negative 18 over 27 over 2, which is 9 over 2. Yeah. Okay, let's do denominator. Oh, it's only 1, right? Copy. Oh, a lot of work. Okay, so let's move this one. It's 1, right? So we have x equal to 0 to 3 y equal to 0 to negative x plus 3 and 1. Yeah, dy dx. Okay, now x equal to 0 to 3 and y, right? Y equal to 0 to negative x plus 3 dx. So we have a negative x plus 3 dx. All right, so we do integrate so we have a negative x squared over 2 plus 3x and x equal to 0 to 3. All right, so then we have a negative 3 squared over 2. And writing is crazy. Plus 3 times 3. Okay, we get negative 9 over 2 plus 9, right? Okay, that will be negative 9 plus 18 over 2, which is 9 over 2. Yeah? So we had a 9 over 2 earlier, right? So we get, uh, let me just, oh, I was looking at that. Sorry about that. Y over mass. Then we have a 9 over 2 over 9 over 2, which is 1, right? Okay, let's do for y. Okay, so let's do this one, numerator first. Or can you do together everything? Because we had experience already, right? So we know a little bit. Oh, okay. So equal to x equal to 0 to 3, y equal to 0 to negative x plus 3, and then y then times 1 dy dx. Yeah. Okay, now, so we do integrate respect to y equal to 0, dx, and then 1/2 negative x plus 3 to the squared. And what we had earlier, we had this one, 1/2, 9 minus 6x plus x squared dx. And so we have 9 over 2. Let's do integrate and then everything do together. Yeah. Oh, I said that we should do the numerator denominator at the same time, but I have not done that. Okay. Let me do that. Okay, so copy, paste. All right. Uh, integrate x minus 3x to the second power over 2. Yeah. Look, I distribute, then that's negative 3, right? And then integrate x squared over 2. Make sense? All right. Plus x third power, and then 1/2 times 1/3, which is 1/6. Yeah. And then we want to evaluate x equal to 0 to 3. Almost done. 9/2 times 3 minus 3/2, 3 squared plus 1/6, 3 to the third power. Yeah. Okay. Let's calculate. Okay, so I calculate this one. So we have a 9/2, but then we had this one earlier, right? From the sen of x, sen of mass from the x, yeah? So that's also 9/2. So we will have, this is better, right? Copy. Equal to 9/2 over 9/2, which is 1. So we call this is a centroid, right? If the density function is constant, we call them, let me write down the um, the center of mass is 1, 1. We call this is a centroid since the density function is constant. Okay. Okay. Now we have a moment of inertia. Okay. So we talked this one earlier, right? So it measures the tendency of the mass to resist a change in rotational motion about an axis, right? Okay, so we have moments of inertia. So we denote I sub x. Okay, so I sub x is about the x-axis. So this means rotate to y, then to resist to rotate again. So we have a y squared. Make sense? We have x-axis, and then we rotate to the y-axis. Then, if we rotate again, that's the x-axis, right? But they did not. They resist to rotate. So y squared there. Can you see that? Why we have a y squared? All right. Now, and then we are using density function here. Okay, now we have same concept with moment of inertia. So I sub y. So it's about y-axis. Then we rotate to y. I'm sorry, to rotate to the x-axis, right? That's why we have x. And then we do resist to rotate. So x squared. Make sense? That's why we have x squared here. All right. Now we have, if we have moment of inertia of object about the origin, then it's a polar moment of inertia. Okay, so we can just simply using this one, or we have a double integration of x squared plus y squared, which is r squared, right? That's why polar, right? And then we have a density function. So I'm gonna show you how to use this one together. All right, so let's do the problem. Okay, so we have example triangular region R, and we have different vertices with a previous example. Yeah, so I plot the point. So this is 0, 0. And this is a 2, 0. This is a 2, 2. So if I draw a triangle there, then we can see that this is y equal to x, because from intersect, y-intercept, right? So up, rise, run, right? So it's x. Okay, now we want to find moments of inertia, right? So the formula is I sub x equal to double integration y squared, the density function, all right? Okay, so we have a density function which is xy. So this is xy. Then let's multiply together. So we will have, let's make x equal to 0 to 2, right? So 0 to 2, x equal to 2, y equal to 0 to x. Yeah. All right. So we have x, y to the third power, and dy dx. Okay. Now we integrate with respect to y. So do first. So treat x as constant. So we have x equal to 0 to 2. X is constant, y to the fourth power over 4. And then we evaluate from 0 to x dx. All right, then we have x equal to 0 to 2 and x over 4. Oh, x to the fourth power, right? That's it. Very simple. So nice. We don't get suffered by combining. All right, so we have x to the fifth power over 5. All right, so integrate with respect to x. So x to the sixth power over 6, 0 to 2. So we have a 2 to the sixth power over 6. Yeah. All right. So we simplify. Okay, so I realized that I made a mistake, yeah? Good thing I found out right now. So it's a 4 there, right? Okay, so I don't make a mistake, right? So x to the fifth power over 4 and x to the sixth power over 4 of 5 then, yeah? Is it 5? Hold on a second, I made a mistake somewhere, huh? Yeah, so why I said it, yeah, right? So 6. No, yes. All right, so I'm missing 4 there, yeah, okay. Yeah, all right, so we have 1 over 4, right? Then we calculate 2, 2, so 4 there, and 1 more there, so 3 there, and then 3 there, right? Okay, so we will get 8 over 3. Yeah. Okay, so we want to find moment inertia about y-axis. Then we have the formula here, right? Okay, then we had x equal to 0 to 2. 2, right? Okay, not 3. All right, and then we have y equal to 0 to x. And then let's multiply together. So we have x to the third power y dy dx equal to x equal to 0 to 2. We do integrate respect to y and treat x as constant. All right, so we have x is constant, so x to the third power, y squared over 2. We want to evaluate from 0 to x dx. All right, x equal to 0 to 2, and then x to the third power of 2, and then y squared, x squared dx. Yeah, so we will get x to the fifth power of, oh, I have to be careful, 2, yeah. And we want to, not yet, be careful, not yet, crazy. All right, so dx. All right, now we need to integrate, right? So x to the sixth power over 2, and then over 6. Yeah. Okay, so we want to evaluate x equal to 0 to 2. So hold on 1 second. Oh, x is missing. All right, then we have 1 over 12 and 2 to the 6th power. Okay, we simplify. Then we have, or similar with the earlier one, right? So we had a 1 over 4 earlier. We have a 1 over 2. Everything's the same. So we will get times 2 then, right? So we have 16 over 3. Yeah, we had 8 over 3 times 2, so 16, right? Okay, very good. We need to find moment of inertia of object about the origin, right? So let's bring the formula. So this is the one. Yeah. By the way, we can express as a polar. I didn't write down here. So since we are here, let me write down. So we have not equal to, we can express double integration reason r squared, and then density function r cosine theta or sine theta dA. We can express this way, right? Because we know that where x squared plus y squared equal to r squared, we talked earlier, and then x equal to r cosine theta and y equal to r sine theta, right? Okay. All right, so let me copy paste this formula so that we can use that. Oops. Okay. All right. So we do. Ooh. Okay. I should write down. So we have moment of inertia about the origin. So we have I sub x, I sub y equal to double x squared plus y squared, or x, y, dA. Okay. Let's do it. Let me write down limit first. So we have, let's do double integration first, because we are taking calculus 3, right? Then we check this one later. Yeah. All right. So x equal to 0 to 2, right? And y equal to 0 to x. And then we have x squared plus y squared. And then density function, we had xy, right? Okay, so xy, dy, dx. Let's multiply, distribute, actually multiply. Y equal to 0, y equal to x. So we have x to the third power y plus x y squared. Wait a minute. X to the third power y, right? So x, y to the third power, right? Good. Dy, dx. Okay, now let's integrate. So term by term, right? All right, so let me write down first and treat x as constant. All right, so x constant, so we keep that. Y, we have to integrate y squared over 2, and plus the second term, x is constant, y to the fourth power over 4, and then we want to evaluate y equal to 0 to x dx. Yeah, all right. X equal to 0 to 2, and x to the third power over 2, constant. We have x squared, and plus x over 4 constant, and x to the fourth power dx. Yeah, all right. X equal to 0 to 2. We have x to the fifth power over 2 plus x to the fifth power over 4. Oh, combining like term. Yeah. So we have a 3 x to the fifth power over 4. Not yet. All right, dx. Okay, now root over 4. Integrate with respect to x, x to the sixth power over 6. We want to evaluate x equal to 0 to 2, right? Okay, now 3 over 4 and 2 to the sixth power over 6. Yeah. Okay. Oh, we had experience earlier, so 2 to the fourth power, I'm sorry. 4 with a 2 there, right? So we have a 2 to the 4th power. And then 2, so 2 to the 3rd power, right? And 3 with a 3, right? So we have 8 there then. Okay, let's find out. Check it out. All right, so we have moment inertia about the x-axis and the y-axis. We added them. So I have 16 over 3 about the y-axis there. And we have 8 over 3 about the x-axis. Check. Oh, didn't I copy? Okay, so let me just write down more easier. So check. The moment inertia about the origin, I sub x plus I sub y, which is 8 over 3, I believe, 16 over 3. Yeah. So it's 24 over 3, which is 8. Yeah. Okay. So we got that. Very good. All right. So now we have a center of mass and moment of inertia in 3 dimensions. So we have a triple integration here. Okay, so let me see. Yeah, highlight. So we have region Q, then we have a density function rho. Then how do you find the mass? By using triple integration, then density function, and we are using volume. Yeah, okay. Then we have a moment. We have a center of mass. And then we just learned that, right? Moment of inertia, right? So we have that. Okay, now we have example. So let's just finish in one problem because it's a lot of work. Yeah. So triple integration, we are using only the mass. Okay, now we have region Q bounded by this equation, and then we have a density function, find the total mass. Yeah. Okay. So they say that the region Q is tetrahedron. Tetrahedron means solid with a forward triangular face. Well, here's one of them. Yeah. So there is 3 more in the space, right? Okay, now they have vertices. How did they found? So we have bounded by this equation, right? So if we set it up when x equal to 0, y equal to 0, this is 0, this is 0, then z equal to 2, right? So z equal to 2. So we can make a triple oral pair. So 0, 0, 2, right? Okay, same equation we are using when x equal to 0, z equal to 0, then y equal to 3, right? Okay, so y equal to 3, then 0, 3, 0. And same concept, y equal to 0, z equal to 0. So y equal to 0, z equal to 0, x equal to 6 then, right? So x equal to 6. So that's how they found the vertices here. So 0, oh, sorry, 6, 0, 0. Yeah, 6, 0, 0. Yeah, 6, 0, 0, 0, 0, 2, 0, 3, 0. Yeah. All right. Now let's find the limit. So we have equation. Then solve for z. Solve for z. Then two terms are other side. So we will get 6 minus x minus 2y. Yeah. All right. Now we have a 3z. So divide by 3 both sides. So let us denote this way. Yeah. Okay. Now, when z equal to 0 from the equation, z equal to 0. When z equal to 0, we have experienced earlier, right? So x plus 2y equal to 6. Okay, then solve for y. So y equal to, move other side. So 6 minus x. 6 minus x. And divide by 2, right? So let's make this way. Then we will get 3 minus x over 2. Yeah? All right. Now, when y equal to 0, yeah, from this equation, sorry, you cannot see, then x equal to 6, right? So let me using this equation. From this equation, x plus 2y equal to 6, then x equal to 6. Yeah. So we are using this limit, and lower bound, lower limit will be all zeros. So let's set it up. Okay. So we want to find the mass. So they're using the first letter n, and then triple integration of reason Q, and density function, and the volume, right? Okay, so look, x has a number, so this will be the last. So x equal to 0 to 6, and y is more simpler, so we're using y is second, and z is more complicated, we're using that. So should I use just 1/3? Okay, let's use 1/3, 1/3 like this instead of simplification. Okay, so z equal to from 0 to 1/3, 6 minus x minus 2y. All right, so density function, we have x squared yz. So x squared yz. Then we want to integrate dz, dy, dx, that order, right? So let's do that. So do first treat z as, sorry, yx, y and x as constant. All right. So we have x equal to 0 to 6, y equal to 0 to 3 minus x over 2. Okay, so x squared y is constant. So keep that constant and integrate with respect to z, so z squared over 2. Yeah, and then we do evaluate from z equal to 0 to 1/3 6 minus x minus 2y dy dx. Yeah, okay. Now x equal to 0 to 6, y equal to 0 to 3 minus x over 2, and x squared y over 2, constant. And then z squared, so we input this one into z. So that will be 1/3, 6 minus x minus 2y, quantity squared, dy dx. Yeah. Okay. So that will be, look, let's make a note. So there will be 1/9 because we squared up. And then that means 6 minus x minus 2y, 6 minus x minus 2y, right? Now we can distribute everything. All right, so if we distribute to everything, I have y equal to 3 minus x plus 2. Okay, so 9 and 2, we have 18. So x squared y over 18, they are constant. And then we will have 36 minus 12x minus 4y plus x squared plus 4y squared plus 4xy. Whew. Okay, hold on 1 second. No space. Come on, come on, come on. Okay, plus 4xy. Then we have to make a dy dx. Yeah, so this one, this one will be here. Yeah. All right. Okay, what is next? We need to distribute this one, everything, right? Okay, then I have x equal to 0 to 6, y equal to 0 to 3 minus x over 2. Okay, the first term we do distribute, we have 2 x squared y. Second term, we do distribute 2/3 x squared x to the third power y minus 4 over 3 x squared y squared for the third term, and fourth term we have x to the fourth power y over 18, right? Okay, the next term we have plus 2 over 9 x squared y to the third. Next term is the last term, which is plus 2 over 9 x to the third power y squared. And then we make a dy dx. Yeah. All right. So we want to integrate with respect to y. Treat x as a constant. All right. So we have x equal to 0 to 6, y equal to 0 to 3 minus x over 2. Okay, now I don't need this, right? Because we're gonna integrate right now. Okay, x is constant, so let's take a look. First one, y squared over 2, yeah? Then we have just x squared, y over, let me just write down everything, yeah? Okay, so we have 2x squared, y squared over 2, yeah? Let me write down under the y, so we know we integrate with respect to y, okay? Minus 2/3, x to the third, y squared over 2, yeah? Minus 4 over 3, x squared, x to the, I'm sorry, y to the third power over 3 plus x to the 4 over 18, y squared over 2. Okay, plus 2 over 9, x to the second power, y to the fourth power over 4, plus 2 over 9, x to the third power, y to the third power over 3. So y equal to from 0 to 3 minus x over 2. Okay, so we evaluate when y equal to 3 minus x over 2. We input when we see the y, yeah? Okay, let me make a pause. Let me write down everything because it takes time. Okay, so I inserted everything for y. 3 minus x, 3 minus x over 2, right? Can you see that? And then simplify 2 over 2. And then simplify 2 over 2, then insert. And multiply 4 over 9, and then y to the third power. And then multiply 18 times 2, 36, and then input the y square there, and answer. Yeah, please take a look. Okay, now let me move here. So this one, I have this one too. So last two, right? Yeah, these two, last two. Okay, now I am using the formula expand in order to distribute, right? So expand this one here, and expand this one here, and expand this one here, expand, yeah? Okay, now I multiply, distribute everything. I did a lot of work for you, okay? So look, it was pain in the neck. Look, and then I made a mistake. I could not figure out where I made a mistake. Oh my gosh, it was miserable. Okay, so here, but finally I got the right answer. So after I distribute everything, we have only x term. And then we need to integrate with respect to x. Before that, I have to combine like term, yeah? That is a lot of work. So combining like terms, so pink with pink here, and then blue mark x to the third here, and then x to the fourth power, green mark here, and x to the fifth mark is the purple here, and then x to the sixth. term is orange mark. Is it orange this one too? Yeah, 6. Doesn't look like orange. Okay, hold on a second. This is orange. 6. Yeah. Okay. Now we have this one, missing the x. So we want to integrate with respect to x. This is what I got. X to the third power over 3. X to the fourth over 4. X to the fifth power over 5. X to the sixth power over 6. X to the seventh power over 7. We do keep the constant, right? Okay, now we do evaluate from x equal to 0 to 6. So insert 6, calculate. I have 108 over 35, which is same answer as the textbook. Yay! I'm so proud. Okay, thank you for watching. I will see you in the next lesson. Thank you, bye.